Hello everyone. Today we will discuss monotonicity of the function. Monotonous means in single phase, in single direction. If a function is continuously increasing, it is called monotonically increasing function. If a function is continuously decreasing, it is called monotonically decreasing function. So today we will discuss what is the condition for monotonicity of the function. So first case mein, this is a monotonically increasing function. You see at point x is equal to a, the function takes the minimum value and then it continuously rises, and at point b, x is equal to b, the function takes the maximum value. If in between you take any point x and you proceed a small distance dx, you see dy is positive once the function is increasing at point x. At point x, what I did? I move a dx distance here. During this movement, function rises from this point to this point, means dy distance it rises. Correct? Means what? Here dy by dx is greater than 0. Means it is positive. It means once x increases, y also increases. In case of what? Monotonically increasing function. Correct? This concept you have to grab. What is the meaning of dy by dx greater than 0? Means once x variable increases, y value also increases. Now come here in lower graph. You see at any point x, what I did? I moved a dx distance further on x-axis. I moved a dx distance further on x-axis. Function falls from this height to this height. Means dy height, it fall down. What does it mean? X increases, y decreases. Means what? Dy by dx is less than 0, or you can tell it as a negative. What does it mean? Monotonically decreasing function. So here we got the condition for checking the monotonicity of the function. What you will do? Suppose a function y is equal to fx is given. Y is equal to fx is given. We don't know it is monotonically increasing or monotonically decreasing because we don't have a graph. We only have an equation. So seeing the equation you cannot tell. What will do? You just find out dy by dx. Means f dash x you find out. So whatever the function is given, your first target should be find out its differential. Dy by dx is equal to f dash x, and if this comes greater than 0, monotonically increasing function. If it comes less than 0, monotonically decreasing function. That is the concept you have to understand. Correct? Now you got the point. So क्या definition हुआ? Suppose for every x belongs to closed interval a b, if f dash x is greater than 0, the function is monotonically increasing. इसी तरह से mathematical formulation में we can write for every x belongs to closed interval ab, if f dash x is less than 0, function is monotonically decreasing. This is the definition of monotonicity and condition for checking the monotonicity of the function. Here I have taken monotonous function. Correct? Now we will see the mixed function. How we'll check the various intervals where it is monotonically increasing and the interval where it is monotonically decreasing. Now you see a mixed function. Here function is divided into 3 intervals, a to b, b to c, c to d, depending upon its behavior. From a to b interval, function is monotonically increasing. From b to c, function is monotonically decreasing. And from c to d, function is again monotonically increasing function. So here if you will check here you will get dy by dx greater than 0. in the interval b to c, if you check function's derivative dy by dx, it will be less than 0. And in the interval c to d, again once you check dy by dx of the function, it will be greater than 0. Or in else case, in reverse case, the interval where dy by dx comes greater than 0, in that portion function is monotonically increasing, and the portion where dy by dx is less than 0, in that portion function is monotonically decreasing. So actually what we have to see, dy by dx itself is a function, correct? सपोज फंक्शन एफ एक्स का डेरिवेटिव क्या है, एफ डैश एक्स को वी आर टेलिंग डी वाई बाई डी एक्स, तो इट इज ऑल्सो ए फंक्शन, यू कैन टेल इट एज ए जी एक्स. तो व्हाट वी हैव टू check, we have to check gx functions negative zone, positive zone, negative zone, positive zone. Once we will find this interval, we can easily tell the behavior of function fx in these intervals. So what we have to do, key point is that you have to find out the intervals of gx function, means derivative function, where it is changing its sign, and in this interval you can tell the behavior of function fx. So interval will be made on the basis of derivative function, and behavior is predicted for the original fx function. That is the key point we will use in the further example. There you can very well understand how we are applying the monotonicity principle. Now in continuation, we will learn one important theorem about rational function. Suppose if gx function comes in form of rational function, means derivative comes like this, and so many times it will come like this only: x minus a power m, x minus b power n, x minus c power q, and x minus d power p. In that form, if we get the derivative function, then there is a theorem for checking the sign convention of this function. Means rational function के लिए there is a law. What is that law? First we will find its critical points. That is critical points. What is critical points here? Means the point where the function is taking 0 value or infinity value. So x is equal to a, b, c, d. These are the critical points. What we'll do? We will plot this on a number line. A, b, C and D. ठीक है? Here we are assuming B is greater than A, C is greater than B, and D is greater than C. Means increasing order में we will arrange and make this interval. Correct? Now what you have to do? You have to check the sign of gx in any one of these. This is our choice where we will check. So if we will check in this interval, means less than a, if x is less than a, what is the sign? Only we have to check the sign of function gx. So suppose it comes positive. So we will put here positive. Then in the rest interval, we don't need to check the sign. It will alternate. Minus, plus, minus, plus. Correct? So this is the theorem for the rational functions sign conventions. But here condition is that ki A, B, C, D must be odd. Correct? If the powers are of odd powers only, then this alteration of sign will be valid. Suppose for if n is even, this is even. Means what? कि B critical point का जो power है x minus b power n, this is even. Means this point. तो यहां पर there will be no sign alteration. मतलब क्या होगा? Suppose A is here, it is coming positive, it will come negative. अब B critical point के corresponding power even है, तो क्या होगा? ये this will not, the function will not change its sign. Even power पे, even critical points पे there will be no change in sign. Odd critical points पे there will be change in sign. That you have to understand. Means in this case M, N, Q, P. Suppose M, Q, P are odd and N is even. So what it will do? A point means power M point. Critical point of power M. It is odd. So here it will change the sign. Then B point, it is even, it will not change the sign. Then comes C. C point, Q is odd, it will change the sign, means it will become positive. And then D, here also it is odd, then also it will change its sign. So each and every critical point should be checked for its powers. If powers are odd, then it will change the sign. If powers are not odd, then it will unaltered. The sign will be unaltered. Whatever sign is in the earlier interval, the same sign will follow in the next interval. So this is the way for sign conventions of a rational function. So many times you will get derivative in form of rational functions. In that case, this type of interval should be made easily. Then we can further analyze the original function fx. Now let us understand with help of one example. One question is there, find the interval of monotonicity of a function fx is equal to 2x square minus ln x, where x is greater than 0. So we have to find out the interval of monotonicity of the function, means where it is increasing, where it is decreasing. So first point, what we will get? We should get gx function, that is nothing but derivative of this function. So what will be the value? This is 4x minus 1 by x. And once you will do this 4x square minus 1 by x, and this is equal to x square minus 1 by 4 divided by x, and this is equal to 4x plus half into x minus half divided by x minus 0. So we will find out the critical points. What is the critical points? Critical points of function. X is equal to minus half, 0 and half. Numerator के critical points और denominator के critical points दोनों we will consider. Where numerator factor is 0 becoming 0, that also be critical point. Where denominator factor will be 0, that also the critical points. Now what we will do? We will plot it on number line. Minus half, 0 and half. And this is the intervals. Critical points means there is possibility at that point where the derivative will change its sign. Okay. So you see here each factor has a power 1, 1 and 1, means odd power. So there is no risk of not changing sign. Everywhere the sign will be changed alternatively. So what we have to do? We have to do only one checking. Suppose here I am checking the sign of the function. Rest, without checking, I will alternate the sign. So let us check the sign in this interval. Here in this interval, x is less than minus half. This will be negative. This will also be negative. And this will also be negative. Means 2 negative, multiplication upper. Here also negative, means net is negative. So in this interval, the gx function will take negative sign. Then this will be positive, this will be negative, this will be positive. We have got the clue. So here you see gx is what? F dash x is less than 0. Here you see f dash x is greater than 0. If you here see f dash x is again less than 0, and here also f dash x is greater than 0. Means what? Fx is increasing function in the domain x less or equal to minus half. Minus half to 0. Achha, 0 pe function is not defined, the 0 will not be included. Here it is missing point. Correct? Because 0 critical point is in denominator. So f dash x is positive from in which interval? Minus half less or equal to x and less than 0. In this interval, f dash x is positive, means fx will be increasing function. Now come to the third interval. Here you see again f dash x is less than 0, means decreasing. Fx is decreasing function 100%. What is the interval? 0 will not be included. So 0 से बड़ा और half से छोटा. Equality मैंने यही include कर लिया. And last interval will be again f dash x is positive, means fx will be increasing function when x is greater than half. तो इक्वलिटी वाला साइन यहां इंक्लूड कर लिया है, तो दिस इंटरवल मस्ट बी excluded from equality. I have found 4 intervals where the monotonicity of the function is alternatively changing. Somewhere it is increasing, somewhere it is decreasing. That way we can analyze the monotonicity of the function. तो आज के लिए बस इतना ही. If you like the video, then please give a like button and please subscribe my channel so that I can also be motivated for uploading more videos that may be helpful to you. Thank you very much.